Friends, I am here to present certain mathematical topic to you, and in my experience, the lectures are always given in the form of words spoken by somebody like me. And you are there as a student and you are trying to absorb whatever I am saying. The absorption will increase provided your attention is completely focused. So I want you to isolate yourself completely. Like you sit in a meditation, you should listen to my lecture. The promise is that at the end of this lecture, you will be an expert in the subject called complex numbers. First of all, I hate this word complex numbers. Complex numbers are not at all complex, but it is one of the most beautiful creation of a mathematical object by mathematicians, and you will really enjoy the beauty of this subject called complex numbers if you travel along with me into this lecture. And I'll make it very simple, and I will reduce it to the common sense level. Now I promise you that at the end of first lecture, that is lecture number 1, what will be covered? I'll be covering a number, a strange and fantastic numbers called I. What is this I? I doesn't stand for me. I stands for imaginary number. Why it is called imaginary, God only knows. But it is called imaginary number because other numbers are called real. So this has got to have a different name. So it was called imaginary. But it is not at all imaginary. As far as we are concerned, we are going to write it. So it cannot be in our imagination. It can be a real number as any real number. But they are called imaginary. It's called imaginary quantity. So I'm going to introduce this quantity to you. After that, we'll do certain properties of this quantity called I. And thereafter, we'll create a new number, as I said, the most beautiful quantity called complex numbers. Once I introduce these complex numbers, then we'll find out how they are combined. Mathematicians all over the world have got only one game going on. Whenever they find with numbers, they are always, they are always playing with numbers. The numbers, the moment they introduce numbers or create numbers, they want to add them, multiply them, divide them. So usual games that you know. So we'll be playing those games with complex numbers. That is called operations on complex numbers. Then we'll be finding out certain more things about complex numbers called conjugate of a complex number. What are the properties and what is the thing called modulus of a complex numbers, and all these things will be covered. And then I'll illustrate all these concepts with the help of some simple, very elementary examples. Okay. In the course of lecture, I am 100% sure there will be questions because this is not a classroom. This is an online presentation. So I cannot be in contact with you. So during my presentation, whenever you have any kind of lectures, just underline that and then send it on my email address, which will be given to you at the end. And it is PM Zakatdar, Prime Minister Zakatdar, at gmail.com. So just remember it and just be with me. Focus as if you are meditating. So, number 1, so these are the topics which I spoke about, and these are the topics I'm going to cover. Now I'm going to erase it, okay? So, let us see what is I. I. It is called imaginary unit. Numbers have always evolved according to the needs of the mathematicians. So if the mathematicians find that a particular operation is not tenable or not possible, they used to create new numbers. And this habit created or reached at this stage to invent this particular number. For example, we all know that squares of all real numbers are always positive. X into x is always x square. But if x is positive, and then x square is positive. If x is negative, then also x is positive. You can see that -2 multiplied by -2 is 4. Whereas 2 multiplied by 2 is always equal to 4. So no matter whether the number is positive or negative, the squares are always positive. So what is the reverse operation of square? Square root. So if you take, if you ask yourself what is the square root of 4, then your answers are plus or minus 2 because their square is 4, correct? So this is the answer. So this is a square root of 4, right? Square root of 4 is generally considered as plus or minus 2. Of course, there is some mistake here, but let us assume it right now. Okay. So now square root of 4 is positive. So for example, if I ask you, what is the square of minus 3 then? What is the square root of minus 3? What is the square root of minus 3? If at all there is such a number, then minus 3 will be square of that number. Suppose minus of root 3 is x, then x square will be minus 3. You know this equation is not satisfied by any real number. No real number can have square which is equal to minus 3. That is why we have to create a new quantity, and that quantity has a magical effect on the mathematical universe of numbers, and that quantity is called imaginary unit. So we have defined it like this. Okay, we do not know what it is, so root of minus 1, we'll just assign one alphabet to it, and I will call it I. Now what is root of minus 1? It is I. What is I? It is imaginary unit. It is just a number which we have created, and it means it has got a fundamental property that if you square it, you will get minus 1. Correct? If you square it, you will get minus 1. Now this property creates a new set of numbers which are very, 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 very useful in mathematics, in engineering, and in a lot of other subjects like physics and all that. Okay? So I square is equal to minus 1. This is the fundamental property of I. Okay? Once you understand that I square is equal to minus 1 or root of minus 1 is I, then it becomes quite easy to find out certain properties of it. Okay? So for example, so now, for example, suppose I take I. Okay? I. What is I? According to our definition, it is root of minus 1. Fine. Then what is I square? I square will be minus 1. Correct? What will be I cube? I cube will be what? I square into I. Which means what? I square is minus 1 into what? I. So that will be what? Minus I. Okay? Now what is I raised to 4? I raised to 4 will be I cube multiplied by I. But I cube is what? Minus I, and multiplied by I, that gives you minus of I square. But I square, we already know that it is minus 1. So this is minus 1. Very strange. No other real number can have this kind of fantastic properties. I is minus 1, I square root of minus 1, I square is minus 1, I cube is minus I raised to 4 is 1. I'll again summarize it here. I raised to 1 is root of minus 1. I square is minus 1. I cube is minus I, and I raised to 4 is 1. Now hereafter, you will start getting the same numbers again and again and again and again. For example, if I want to find out I raised to 5, what will it be like? It will be I raised to 4 multiplied by I, isn't it? But I raised to 4 is 1. So it is 1 multiplied by I. So I will get my I again. So I am at the first step again, back again. So what is I raised to 6 then? So I raised to 6 will be I raised to 5 multiplied by I. Now what is I raised to 5? Just now we have calculated. It is equal to I multiplied by I. So it becomes minus 1 again. So I raised to 5. I raised to 5 is I. I raised to 6 is minus 1. As you might have guessed, what will be I raised to 7? It will be minus I. What will be I raised to 8? It will be again 1. So you can see this cycle keeps on repeating itself. You know. So 1, 2, 3, 4. Again 5, 6, 7, 8. Again. Now you can immediately tell me what is I raised to 9. I raised to 9 will be equal to what? I. Then next will be minus 1, I raised to 10 will be minus 1, I raised to 11 will be minus I raised to 12 will be 1. So this cycle keeps on repeating. So therefore, powers of I are repetitive in nature. Same powers come and come again. It's a cycle of I minus 1 minus I 1, I minus 1 minus. So I minus 1 1. These are the only powers. So this gives you some concept about powers of I. That means if I want to find out any power of I, what will I do? Let us see. So suppose I want to find out, let us say I raised to 11. Okay. I raised to 11. I know that there are cycles of 4. So 4, 4, 4. So I will have to subtract the multiples of 4 here. So if I divide 11 by 4, so divide 11 by 4. Divide 11 by 4. So what is that? 4 to the 8. So it will be 8 here. And this is the remainder 3. So I can write 11 actually as 4 multiplied by 2 plus 3. This is called remainder theorem. All of you know this. So that means I raised to 11 is what? I raised to 4 multiplied by 2 plus what? 3. I raised to 4 multiplied by 2 plus 3, which means I raised to 4 raised to 2 multiplied by I cube. Correct? But I raised to 4, we have seen it is 1. So this part will become 1. So it is only I cube. And what is I cube? What is 3? 3 is a remainder after dividing 11 by 4. So if you want to find out power of I, whatever the number the I is raised to, the algorithm is very simple. Divide it by 4, find a remainder. And whatever that remainder, because if you are dividing by 4, the remainders, there are only 4 possibilities. Either the remainder is 0, or it is 1, or it is 2, or it is 3. These are the only possibilities whenever you divide by 4. So I raised to 0 will be 1, I raised to 1 will be I square will be minus 1, and I cube will be minus I. So these are the only answers possible for any power of I. So how to find out, what is the algorithm for finding out powers of I? Let us see. Simple. So if I want to find out, if I want to find nth power of I, what should I do? Step number 1. Divide n by 4. Right? Find out remainder. Now step 2. There are 4 possibilities. Remainder could be 0. If the number is divisible by 4, for example 12 divided by 4, remainder will be 0. Or remainder could be 1, or remainder could be 2, or remainder could be 3. It cannot be 4. Right? So these are the only 4 possibilities. And then step 3, you got the power. Right? So step 3, find out I raised to remainder, whatever that remainder is. I raised to remainder, and this remainder is obtained by dividing the n number by 4. For example, let us see. So suppose I want to find out I raised to 42. So I raised to 42. So 42 will be divided by 4. But we know 42, if I divided by 4, then 40 is a 10th multiple of 4. So therefore, the remainder is going to be what? Correct? So friends, I have drawn this particular diagram. Have a look at it. You can understand the first row gives you the power of I, and this second is the calculation of it. So I raised to 1 is I square is minus 1, I cube is minus I raised to 4 is 1, again I minus 1, I 1, I minus 1, I 1, I minus 1, I 1. This is the repetitive nature of the powers of I. So if I ask you, what is I raised to 1 plus I raised to 2 plus I raised to 3 plus I raised to 4? You will get the surprising answer I minus 1 minus I and plus 1. So the answer is going to be 0. Now thereafter, the next 4 powers if you add, again they will be 0 because they are same. So that is how the powers of I will appear. For example, if I ask you, what is I raised to 1 plus I raised to 2 plus I raised to 3, right up to I raised to 100. Now if I want to answer this particular question, then you will realize that 100, there are 100 powers, right? And every fourth power if you add, so first, second, third and fourth power if you add, right? So this group of 4 will add up to what? 0. Another group of 4 will add up to what? 0. So how many groups of 4 are there? Because total numbers are 100. So therefore 25 plus 25 plus 25 plus 25. So there will be 25 groups of 4 units, and therefore each unit will be contributing only 0. So obviously this answer is going to be what? 0. Why? Because 100 numbers, 100 powers, 100 consecutive powers of I, if you take, then 4 power will add up to 0. Next 4 power will add up to 0. Now if you divide 100 into groups of 4, there are 25 groups. Each group gives you 0. So the answer is going to be 0. Okay. Another way of looking at it like this, that I raised to 1 plus I raised to 2 plus I raised to 3, etc., I raised to 100. This, if you know from the another topic called geometric progressions, this is a geometric progression. Geometric progression is that geometric progression in which the division of the two numbers, two consecutive values is same. So I square upon I is I cube upon I square is I. So therefore, every number, the next number is obtained by multiplying by I. So some of this summation of this geometric progression is given by a formula. That formula is A multiplied by 1 minus R raised to n upon 1 minus R. This is the formula, where R is the common ratio. Common ratio means the ratio that you obtain by dividing the next number term by the previous term. Here, if you divide I square by I, you will get I. So A is the first number. So what is A here? A is I, first term, right? And then 1 minus I raised to what? Now there are exactly 100 terms, so it will be 1 minus 100, right? Divided by 1 minus I again, correct? 1 minus I. Divided by 1 minus I. That is the formula. Now that will mean what? That will mean I into 1 minus I raised to 100. Now I raised to 100 is going to be what? I raised to 100, as I explained, it is 0. So divided by 1 minus I, correct? Now, we have not done how to divide complex numbers. So I will illustrate this again when I've taught you how to divide complex numbers. So this is another way of doing it. You can use geometric progression and evaluate this value. Okay, but that will be dealt with later on, because you do not know how to divide complex number as yet. We'll do it very soon. So let us take another example. Suppose I want to find out I raised to, let us say, 442. I raised to 442. So I told you, step number 1 is what? 442 has to be divided by 4. So 4 ones are 4, so it will be 4 here. This will go minus. So again there will be 4. So again 4 ones are 4. So here it will be what? 4, 0, right? And then there will be 2. Now you cannot divide further, therefore the remainder is 2. And this is this. So the number I raised to 442, so 442 can be written as 11 multiplied by 4 plus what? 2. 2 is the remainder. Therefore, I raised to 442 is nothing but I raised to remainder, and that is I square, which is equal to what? minus 1. Correct? So it's a very clear demonstration of all the steps that I have told you. Okay, fine. So now let us go to the next topic. Now we are talking about integral powers of I. You must have realized that I have talked about I raised to 1, I raised to 2, I raised to 3, I raised to 4. These 1, 2, 3, 4 are called natural numbers, right? And they are integers basically. But integers are negative also. So integers can be negative also. So what are the negative powers of I? Okay. So what are the negative powers of I? Let me find out. So negative powers of I. Negative powers of I. Now negative powers of I will be what? For example, if I want to find out I raised to minus 1, what will it be? According to our normal convention, I raised to minus 1, according to laws of indices, it should be 1 upon I. Correct? Now, suppose I multiply and divide by I here. Okay? So I'm not changing anything. I am just multiplying and dividing by what? I. So divide by I. What will happen? I into 1 will be I, and I into I is I square, and I square I know that it is minus 1. Correct? So that will be what? Minus I. So I raised to minus 1 is minus I. That is a revelation. Why? Very important. I raised to minus 1 is minus I. Thereafter, I have no difficulty in finding out powers of negative powers of I. For example, what is I raised to minus 2? Right? That is minus I raised to minus 2, or raised to 2. Correct? So minus I raised to 2, minus I raised to 2 will be what? Minus minus plus, and I square is minus 1. So I can find out. Okay? So for example, I raised to minus 3. What will it be that? Right? It is I raised to minus 1 raised to what? 3. But what is I raised to minus 1? It is minus I. So minus I cube means minus into minus 3 times. So it will be minus. It will be minus I cube. And minus I cube is minus I. So therefore, the answer is I. Correct? So in other words, if I want to find out what is I raised to minus 11. Okay? I raised to minus 11. Fine. So that is I raised to minus 1, correct? Raised to 11. But I raised to minus 1 is minus I raised to 11. So minus 1 is raised to odd power, so it will be minus ultimately, and it will be I raised to 11. And I know how to find out I raised to 11. 11 is divided by 4. So if you divide it by 4, then the next multiple is 8 and the remainder is 3. So therefore it is minus I cube. So I cube is what? Minus I. Therefore, this will be what? I. Okay. So this is how you can calculate the powers of I, right? So this is the first part of our lecture. Okay. Friends, in complex numbers lecture 1, I gave you the powers of I. Now I gave you an algorithm for finding out powers of I. The algorithm was very simple. If I want to find out I raised to n, then the first step was what? Divide n by 4. Obtain remainder. Obtain remainder. And then the answer is I raised to remainder. Very simple. When you divide by 4, the remainder has to be either 0, 1, 2, 3. Therefore, it will be only one of the three things. 0, 1, 2, 3. That's all. So for example, look at this question. Okay. So look at this question means what? I want to find out I raised to 37 plus 1 upon I raised to 67. That's the question. Fine. So I'll first of all find out what is I raised to. So let us find out what is I raised to 37. I raised to 37. Now if I divide 37 by 4, then you know 9 4s are 36. So therefore it is 36. So remainder is 1. So the answer is I raised to remainder. That is I raised to 1. correct? So this is our first calculation. Second calculation is, let us see what is I raised to 67. So 67 has to be divided by 4. So 4 ones are 4, so 4 here, 2 will be there, then 7, then which is the nearest number? 6 fours are 24, correct? So 6, so 6 fours are 24, correct? Then what is the remainder? 3, correct? So I raised to 67 is nothing but I raised to remainder after dividing 67 by 4. So that remainder is what? 3. And I know I raised to 3 is minus 1, minus I, correct? So therefore, this number happens to be minus I raised to, 37 is I raised to 37 is I raised to 37 is I. We have seen here, and I raised to 67 is minus I. So this total is equal to what? 0. That is the answer to the first question here. Okay? Have you understood it? It's very simple. Okay? Next, let us erase this. First question is over. Now let us go to the next question. Next question is, what is the next question is, I raised to 77 plus I raised to 70 plus I raised to 87, okay, plus I raised to 414, right? And this whole thing is raised to the power 3. The problem looks formidable, but it's actually nothing, because I know 77, 70, these are the big numbers, but they will reduce to only remainders of 4. So if you divide 77 by 4, what do you get? So 4 ones are 4, so 4, here it is 3, 7, then 9 here, 36, so this is 1. So I raised to 77 is nothing but I, plus I raised to 70. So if I divide by 4, then 4 ones are 4, 4 here, 3 here, this is 7. So here it is what? Remainder is 2. So this will be I square. Okay? Now 87. 87 is divided by 4. What do you get? 4 2s are 8, right? Here it is 0, 7, 4 1s are 4. So this will be 4, remainder is 3. So therefore this is equal to I cube. And lastly, 414 is divided by 4. So it will be 1 here, 4 here, 0, then 1, then again 0, then 4, then what will be that? 4 3s are 12. So it is, remainder is 2. So it will be again I square. Correct? So therefore, now let us remove these divisions, okay? So what is this now equal to? This is I will remain I, this is minus 1, this is minus I, and this is minus 1. Okay? So I minus I gets cancelled. Minus 1 and minus 1 becomes minus 2, and minus 2 raised to 3 becomes minus 8. Simple. That's the answer. Okay? Now, so that is the end of this question. Okay? Now let's go to the next one. Next one is based on geometric progression. So let us first of all understand what is GP. GP. So what is GP? Geometric progression. It is like this: AR square, etc., etc. Its nth term is given by AR raised to n minus 1, where R is called common ratio. If you divide next term by A, it will be always constant, that is R, right? So that is called geometric progression, and sum of GP is given by A multiplied by 1 minus R raised to n plus 1 upon 1 minus R. So this is the formula for a GP. So now if you look at this problem, it is 1 plus I square plus I raised to 4 plus I raised to 6. This goes on till you reach I raised to 20. Now I will have to make use of this formula. Here R is the ratio. If you divide I raised to 4 by I square, you will get I square. I raised to 6 by I raised to 4, you will get I square. So common ratio here is I square. I square, okay? And I square is what? Minus 1, okay? And first term, that is A is 1, okay? And then what is N? That's the problem, right? So what is N? This is I raised to 20 is the last term. So therefore I square raised to 10. Therefore this is the 10th term. So N is equal to 10, correct? So therefore I square is equal to 10. So therefore this becomes the 10th term. So N is 10. And then we have this, okay? So now I have to apply this formula. So formula tells me that A is 1. So A is 1. And 1 minus minus 1, I square is the common ratio, right? So that is raised to n plus 1, so that is 11 divided by 1 minus 1, okay? So that gives you 1 minus 1 raised to 11, 11 is odd power, so it will be minus, so minus will become plus, and this will become what? 2, correct? So therefore this whole thing is equal to 1. Correct? Which is a nice problem, okay? Which involves the concept of geometric progression, which you should revise before doing this problem, okay? Fine, let us remove this problem. Now let us do the next problem. The next problem is what? It says 1 minus I raised to n multiplied by 1 minus 1 upon I raised to n. Now in the last lecture I already told you that 1 upon I turns out to be minus I. So let us substitute here. So this becomes 1 minus I raised to n. This becomes 1 upon I, so minus of minus I it becomes, right? And this whole thing is raised to n. So this is 1 minus I raised to n, and this is 1 plus I raised to n. Both the terms are raised to the same power. Therefore, what we are going to do is 1 minus I, will take them together. 1 plus I, the whole thing is raised to what? N. But what is 1 minus I into 1 plus I? The simple calculation A minus B into A plus B gives you what? A square minus B square. A plus B, A minus B is equivalent to A square minus B square, correct? So therefore it is 1 minus I square, right? This is raised to n. But 1 minus I square I know, so it is minus 1. So 1 minus 1 raised to what? N. So that will be 2 raised to n, correct? So this is the value, okay? Fine. So that is how these problems are to be solved. Students, if you have any questions, pick up a problem for the NCERT books of complex numbers and please write it in the comment. I'll give you the solution of that problem in my next lecture. So remember that, okay? Now let us go for the next topic called